Greetings to you all. My name is Joshua, and I welcome you back for this session that I'm going to talk about volume strength of hydrogen peroxide. We are going to use a calculation, and we shall be using potassium manganate 7 solution. We have a guiding question that says that 25 centimeters cubed of a certain hydrogen peroxide solution made by dilution of 5 centimeters cubed of original hydrogen peroxide to make 250 centimeters cubed required actually 24 centimeters cubed of 0.02 molar potassium manganate 7 solution. Now, we are requested to calculate the volume strength of the original concentration of hydrogen peroxide. But first of all, we're going to start by looking at what what volume strength actually means. Volume strength is all about the volume of oxygen produced when 1 mole of hydrogen peroxide is decomposed at STP. What do I mean? I mean this. I have 1 mole of hydrogen peroxide. Let's say this is our hydrogen peroxide. It will always decompose to give us oxygen like this, and also water. If this is our equation, then we shall explain that if we are decomposing 1 mole of hydrogen peroxide, then we shall have a half moles of oxygen. That's what we are trying to look at. However, you can still balance it normally. Of course, you put a 2 on hydrogen peroxide, then you don't put anything on oxygen, and then 2 on water. Then you use it accordingly. Still, it will work, but we just wanted to actually bring it out. What do we mean by 1 mole of hydrogen peroxide? So that's the key word here. Now, moving on and going for the question, we shall say that if 25 of hydrogen peroxide was used, but it was made by, of course, mixing 5 centimeters cubed of the stock solution to make 250. It means the 5 of the stock solution has the same number of moles of 250, since it is just all about dilution. I think that one has not yet changed. Then 2, we are going to use potassium manganate 7 to calculate actually the hydrogen peroxide. So we must be knowing the equation that is involved. Now I'm going to write the half equations, then we combine them and we get the final equation. The half equation for potassium manganate 7 has never changed. Is this. We have the 4 there, and it is a solution actually reacting with the 5 electrons. I just don't want to waste time on this to explain all these issues because we already know, at least we have an idea. And then we have 8 hydrogen ions, just like that. And this is going to be giving us, of course, the oxidizing agent will always get reduced, give us, in this case, manganese 2 ions in solution. And we have 4 moles of water, just like that. That is our first half equation. This is our liquid. Then we have the second equation of hydrogen peroxide instead decomposing. Now it is acting as a reducing agent, so we expect it to just decompose as follows. Hydrogen peroxide, just like this, will always just give us the hydrogen ions, which are always, of course, in solution. You can't have them in liquid. And then we produce oxygen gas along. And then we shall be having at least electrons, which are going to be 2 of them. So we balance this one also by that 2. Now, when you check so well, you realize that we are having 5 electrons up and 2 electrons down. So you can interchange. You multiply the 2 electrons up. This is what I'm trying to mean. You multiply here by 2. Then you multiply this side by 5. So this is going to be producing for us on either side hydrogen ions. So we shall reduce them immediately Or you can first write the equation fully, and you have on either sides, we shall have 10 on the left hand side, and we shall have 16 on the right hand side. So those ones will cancel, will remain with only 6 on the right hand, so on the left hand side. So I want to beg your pardon. I want to say that we shall have 16 hydrogen ions on the left hand side and 10 hydrogen ions on the right hand side. So the ones on the right hand side will cancel with the sum on the left hand side, so remain with the 6 on the left hand side. So in the end, we shall have the overall equation, which just looks like this. I want just to pick it quickly without wasting any time. We shall have 2 permanganates ions, just like this, reacting with 6 hydrogen ions, because we say that they were 16 and 10 were cancelled out. Then we shall have also 5 hydrogen peroxides, 5 hydrogen peroxide moles, just like that. And then we shall be forming for ourselves 2 manganese, 2 ions, just like that. And then we shall have the water and also oxygen with 8 water and also 5 moles of oxygen gas. As simple as that. So we're going to be having such an equation. I hope I've not skipped anything, because at least I tried it out before I did all this. So this is the equation we're going to be using. So 2 moles for 5 moles. We can move on. Now, after establishing that, then we can use the number of moles of potassium manganate 7 to get the number of moles of hydrogen peroxide that reacted. Now we just say moles of the potassium manganate 7 that reacted, that were involved in the reaction, equal to, of course, its molarity, 0.02 moles. We multiply by the volume involved, which volume was 24. Then we divide all this by 1,000. So we shall be able to get the number of moles as actually 4.8 times 10 to the negative 4. So it is 4.8 is 8 times 10 to the power negative 4 moles. So we've established the number of moles of potassium manganate 7. Now, from this same thing, we are going to realize that 1 mole, in other words, in this case, it is 2 moles. Allow me to erase this. It is 2 moles. I want us to use 2 moles because there are 2 moles. 2 moles of the permanganate, potassium manganate 7, react with 5 moles. React with 5 moles of the hydrogen what? Peroxide. This one is very clear. There is no any big deal here. Now, if that is the case, how about if I'm having 4.8, like I got above, times 10 to the power negative what? 4 moles of potassium manganate will react with, of course, 5 out of 2 times the same 4.8 times 10 power negative what? 4. We shall be able to get the number of moles of hydrogen peroxide as 1.2. It's going to be 1.2 times 10 to the power negative what? 3 moles. So we have those number of moles of hydrogen peroxide. But remember, those moles we've just got are the ones for 25, the solution that we picked, which was 25. How about if it's 250? So you're going to say, just move on and inform ourselves that 250, so 250 centimeters cubed of the solution has, of course, we're going to be having 250 itself. Then we multiply by the moles that we got, which is 1.2. 1.2 times 10 to the power negative 3. Then we divide the whole of this one by 25. So in other words, it is just times 10 to the power negative 2. So it's going to be giving us 1.2 times 10 to the power negative 2 moles. But like I told you from the beginning, that those moles are the same as of the 5 of the original. So we say 250 centimeters cubed has same moles as the 5 centimeters cubed of the original. Allow me to write just like that, but I think you're getting what I'm trying to mean. If that is the case, it means that the 5 centimeters cubed of the same hydrogen peroxide of the solution has the 1.2 times 10 to the negative what? Negative 2 moles. If that is the case, how about if it is 1000? So the molarity in this case, just say molarity equals, you get your 1.2 times 10 to the negative 2, of course, times 1000, because that is now the molarity. Then we divide by the volume that we are dealing with now, which is our 5. Okay, so this will give us the answer that is going to be around 2.4 molar. So we have known now the concentration of hydrogen peroxide in this case, and we want to find out the volume strength. So now if I have that, I'll first of all say from the statement 1 mole of hydrogen peroxide, we've already known that it produces a half of hydrogen peroxide, gives us gives what? Gives a half, or 0.5 moles of oxygen. We've known that already from the beginning, or from the statement that I gave. If that is the case, how about what I just got here, the 2.4 moles, 2.4 moles of the same hydrogen peroxide will produce a half, the half of oxygen, you remember? A half out of 1 times 2.4. Of course, this is going to be giving us 1.2 moles of oxygen. So we have that. If those are the moles of oxygen, and we know very well that from the statement that we know very well that 1 mole one mole of a gas, which is oxygen in this case, of course, has a volume of 22.4 liters at STP. How about if I'm having this real one, the 1.2? So the 1.2 moles of the same gas will have the 22.4 out of 1, then we multiply this one by 1.2. And we shall be having this one as the final answer, which is going to be around 26.88. 26.88. So if they ask you for the volume strength equals to 26.188. That is going to be the answer. And there are many other questions which are rated. You can always try them out, you check, and be able to get such kinds of questions. For now, allow me to say goodbye. Don't forget to subscribe and give a comment. If there is any issue that maybe I underrated, you can inform me and it is corrected. I wish you all the best for now, and bye.